Hello everyone, my name is Chong Guan. I'm one of the doctoral candidates in the Innova program. Today, I'm going to present the integration of head tracking technology in noise barriers. Before we talk about head tracking technologies, we need to first understand the different types of active noise control strategies currently being employed. The first one would be the global active noise control that essentially attempt to control noise within the entire enclosure. However, this method will only work at low frequencies, and its performance also depends on the type of enclosure that you have. The second one will be the local active noise control, which only attempt to control noise at a particular region, for example, at your ears. This kind of method, as compared to global control method, can extend to higher frequencies. By only minimizing the noise at a single point, local control can provide a zone of quiet around your ears. There are various applications that make use of local control. One of those applications would be applying active control in headphones, as seen in the figure on the left. While the speaker tries to play audio to your ears, it also has an additional function as to minimize the unwanted noise picked up by the microphones integrated in the headphones, which in turn minimize unwanted noise traveling to your eardrums. The second application would be the active headrest, where the user would not need to wear any wearables, such as your headphones, to achieve this effect. Instead of wearing the headphones, the loudspeakers and its microphones were integrated in a headrest, as shown in the picture on the right, which ultimately create the zone of quiet in your ears as well. Active headrest can be implemented in various scenarios. The first would be the office chair, as shown in the picture on the left, which includes the microphones that extends out from the chair used for control. Active headrest can also be applied in a vehicle or aircraft cabin. For the vehicle cabin, active headrest would be beneficial in removing road noise and engine noise, as shown in picture here, while for the aircraft cabin, noise generated from either the propeller or the turbojet engine are often targeted, as these noise mainly creates discomfort in users. While local control can achieve a higher frequency of control as compared to the global method, it is important to know its physical limit. Take displacement as an example. You will have a noise source placed at this point over here, a loudspeaker that used to control the noise placed here, and the microphone used for control is placed at this point. For low frequency, you can see that although the signal picked up by the microphone and used for the control is only at this red point, you can notice that the noise reduction region applies to the region around the microphone as well. This is what we call the zone of quiet, as the zone reduction occurs around that microphone. However, as the frequency increases, this zone of quiet gets smaller, as you can see for the rest of the figures over here. This essentially means that there is a frequency limit in applying local control, since the microphones are often placed at a certain distance away from the ears. We have seen the physical limit applied to local control. For active headrest in particular, there is one additional practical limit. What if the head moves? We would expect the active noise control performance to degrade since the ears have now been shifted outside that quiet zone. So how do we fix this? This is where the head tracker comes in. By applying a head tracker, you can obtain an accurate position of the head. This position can then be fed to the control system, as shown in this schematic here, to update its relevant input, which will then finally update its controller that provides the new zone of quiet at the new ear's position. Does this work? Previous research had tried to investigate the feasibility in applying a head tracker. As you can see here, when the active noise control is turned on, you would expect a good noise reduction around its ears. However, when the head moves, you can see that there is a degradation in performance when the head tracker is turned off. When the head tracker is turned on, you can see that there is a definite improvement in the control performance as compared to the case where the head tracker is turned off. This would ultimately verify the feasibility in implementing the head tracker in active noise control in tackling head movement. Head tracking techniques can be applied in different noise control applications as well. This application in particular is a smart pad that aims to reduce snoring heard by the user's ear. This can be placed in a sleeper train. especially when there are a lot of other sleeping passengers that tends to snore, which will definitely create discomfort for the user's sleeping experience. When the user is asleep, you would expect the head moves its position over time, which would degrade the noise control performance at its ears. But if you decide to apply some head tracking technique, for example in this case where infrared sensor is used to detect its position, you will effectively improve its noise reduction performance.